We're going to start talking about systems of equations. And a system of equation is just going to be at least two equations that have two variables in them. And both equations have to have the same variables. So if we were going to explain to ourselves or write down what systems of equations are, we would say two or more equations with the same variables. So instead of just having one equation like we had before where we had 3x plus 5 equals 10 and we were solving for x, now they're going to give us two equations and both equations will have an x and a y in them, or they can really have any two variables. You can use any letters, you don't have to use x and y, they just have to be the same in each equation. And when we write our solutions for these equations, we're going to write them as ordered pairs. So solutions will be ordered pairs. And remember, ordered pairs are x, comma, y. So what we're going to do today is we're just going to look at if ordered pairs are specific solutions or how many solutions a system of equation actually has. So we're going to look at different graphs of systems of equations and decide how many answers they have. And then we're also going to look at ordered pairs and decide if the ordered pair is a solution. So since we know that our solutions are going to be ordered pairs, that kind of tells us that we could look at the graphs, right? Because we know ordered pairs are coordinates that we graph. So we have three different types of solutions that we could possibly have. So we could, our first one, I'm going to draw on the x-axis and my y-axis. And then draw on a graph. And now the weirdest thing I think about this for you to get used to is that we're talking about two equations. So it's not just one line on the coordinate grid anymore like we're used to when we were graphing equations. It's going to end up being two lines on the coordinate grid. And if we're looking for the solution, we want the point where they're intersecting. So our solution here is the point where they intersect. So our most common solution is that the graphs are going to intersect at one point. That we'll have one specific point where the two graphs cross over each other, and that point will be our answer. So this has one solution. And I would say that the solution, which is right there, is at negative 1, and 1, because I went from the origin, I went back 1, and then up 1 in order to get that point. So negative 1, 1. One solution right where they intersect each other. So some of your questions today are going to ask you to look at graphs and decide how many solutions they have. So if you see that they're crossing over each other, where they cross is your solution. The next type of solution we can have is if we have two parallel lines. So if I have two parallel lines, I know parallel lines are never going to intersect, right? They're never going to cross over each other. So if I have two parallel lines, I have no solutions. And then every once in a while, they'll end up giving me two equations that are the same. And if I had two equations that were the same and I was graphing them, draw my x-axis and y-axis. If I had two equations that were the same, my first one, and then I also have another one. If they're the same, they're going to fall right on top of each other. And because they're laying literally right on top of each other, they share every single point because they're the same line. Which if I zoom in for you, you can see kind of they're on top of each other, right? Every single point, no matter where I'm looking, here, 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 they're all the same. All their points are the same. So when we end up with two equations that are the same, that's when we get our infinite solutions. So just like when we were solving equations, sometimes we had an answer, sometimes we had no solution, or sometimes we ended up with infinitely many solutions. Same thing here. We just are going to look at it a little bit differently today, where we're going to look at just the pictures of the graph and decide what type of solution the system would have. So the other thing that they can ask us, or they're going to ask us today, is to tell whether the ordered pair is a solution to the system. So they're going to give us a point, and then they're going to give us a system. And we notice that our system is two separate equations. They almost always stack the two equations on top of each other, or if they write them side by side, they'll put a little semicolon in between them, but it's more common you'll see them stacked on top of each other like that. So they're telling us they want to know if 2, 5 is a solution to x plus y equals 7, and 2x minus 3y equals negative 11. So in order for us to decide if it's a solution, we're going to plug the point 2, 5 into both equations and see if it makes the equation true. So in order for the equation to be true, if I'm looking at this top equation, x plus y equals 7, that means when I plug in 2 and I plug in 5, I have to get 7 on the left side since it's saying the entire equation equals 7. So when I plug it in order for it to be true, I have to get the same number on both sides of the equal sign. In order for it to be a solution, it has to be true for both equations. So I'm going to take, I know this is my x value and I know this is my y value, so I'm going to take x plus y equals 7, and I'm going to replace my x with a 2, plus I'm going to replace my y with a 5 equals 7. I know 2 plus 5 is 7, so I get 7 equals 7. So far, this is looking like it's a solution because this is true here. This is a good thing. 7 equals 7. I agree. But I can't say it's a solution until I also check that second equation. I have to also make sure it's true in the second equation. So now I'm going to take my 2x minus 3y equals negative 11. And I'm going to plug in 2 and 5 for my x and y here. So I'm going to end up with 2. I'm going to plug in my 2 minus 3. Instead of y, I have a 5 equals negative 11. And then I'm just going to use order of operations. I'm going to simplify. I'm going to make sure I get the same thing on both sides. 2 times 2 gives me 4, minus 3 times 5 is 15, equals negative 11. 4 minus 15 is negative 11, equals negative 11, which means negative 11 and negative 11 are the same on both sides, so they're true for both solutions. So since this point makes both equations true, it's a solution to the system. If it only made one true, it's not a solution. If it didn't make either of them true, it's really not a solution, but it has to make both true in order to be a solution. So we can say 2, 5 is a solution to the system since it makes both equations true. So you're also going to be looking at systems and deciding if the ordered pair is a solution today.